Imagine taking your very first step into a workout. The moment your muscles begin to contract, your body launches one of the most complex biological reactions it can perform. Within seconds, your heart races, your lungs work harder, your brain becomes more alert, and trillions of cells begin fighting to produce enough energy to keep you moving. Whether you're lifting weights, running, or simply climbing a flight of stairs, exercise transforms nearly every organ in your body. But what actually happens inside you from the very first second until hours after you've finished? Let's find out. The instant you start exercising, your muscles demand more energy than they do at rest. But your body doesn't have time to wait for new fuel to arrive. Instead, it immediately begins using ATP, or adenosine triphosphate, the tiny molecule that powers every muscle contraction. There's only one problem. Your muscles store enough ATP to last just a few seconds. As those stores rapidly disappear, your body switches to another emergency energy system. It begins breaking down a molecule called phosphocreatine, allowing your muscles to keep producing ATP almost instantly. This explosive energy system powers short bursts of intense activity, like sprinting or lifting heavy weights. Meanwhile, your brain notices the sudden increase in activity. It immediately signals your heart to beat faster. Your resting heart rate of around 60 to 80 beats per minute can quickly climb to well over 150 during intense exercise. Every beat pumps more oxygen-rich blood toward your working muscles. At the same time, your breathing becomes deeper and faster. Your lungs begin absorbing more oxygen while removing increasing amounts of carbon dioxide produced by your muscles. Within just a minute, your circulation has completely changed. Blood flow is redirected away from organs that don't need as much oxygen during exercise, like parts of your digestive system, and sent toward your muscles, heart, and skin. That's why exercising immediately after eating can sometimes feel uncomfortable. Your body is trying to prioritize movement over digestion. As your workout continues, your muscles burn through stored glucose. They also begin breaking down glycogen, a stored form of carbohydrate found mainly in your muscles and liver. If your workout lasts longer, your body gradually starts relying more on stored fat for energy. Contrary to popular belief, fat doesn't suddenly begin burning after a magical number of minutes. Your body uses both carbohydrates and fat throughout exercise, but the balance shifts depending on the intensity and duration of your workout. Inside your muscle cells, thousands of tiny structures called mitochondria are working at maximum capacity. Often called the powerhouses of the cell, they combine oxygen with nutrients to generate enormous amounts of ATP, providing the energy needed to keep you moving. The harder you exercise, the more oxygen your body consumes. Scientists measure this using a value called VO2 Max, which represents the maximum amount of oxygen your body can use during intense exercise. Generally, the higher your VO2 max, the better your cardiovascular fitness. As exercise becomes more intense, another change begins to occur. Your muscles start producing lactate. For years, people believed lactate was responsible for muscle soreness, but that's actually a myth. Lactate is a valuable fuel source that your body can recycle for energy. The burning sensation you feel during intense exercise is caused mainly by changes in acidity inside your muscles, not by lactate itself. As your body temperature rises, your brain activates another survival mechanism. You begin to sweat. Sweat itself doesn't cool you down. Instead, when sweat evaporates from your skin, it carries heat away from your body, preventing dangerous overheating. Your blood vessels near the skin also widen, allowing more heat to escape into the surrounding air. At the same time, your brain releases a powerful combination of chemicals. Endorphins help reduce pain. Dopamine creates a sense of reward. Serotonin improves mood. These chemicals are one reason many people feel happier, calmer, or mentally refreshed after exercising. This effect is often called the runner's high, although it can occur during many forms of physical activity. If you're lifting weights, tiny microscopic tears begin forming inside your muscle fibers. That may sound harmful, but it's actually the first step toward becoming stronger. After your workout, your body repairs these tiny tears, making the muscle fibers slightly thicker and stronger than before. Repeating this process over weeks and months leads to muscle growth. Exercise also has powerful effects beyond your muscles. Your heart becomes stronger with every workout, allowing it to pump more blood with less effort over time. Your lungs become more efficient at delivering oxygen. Your bones respond to mechanical stress by becoming denser and stronger, reducing the risk of fractures later in life. Even your brain changes. Exercise increases blood flow to the brain and stimulates the release of a protein called brain-derived neurotrophic factor, often nicknamed Miracle-Grow for the brain. This protein helps support learning, memory, and the formation of new connections between brain cells. Research has consistently shown that regular exercise lowers the risk of heart disease, type 2 diabetes, high blood pressure, obesity, and several other chronic conditions. It also supports mental health by reducing symptoms of anxiety and depression in many people. But the story doesn't end when your workout is over. Even after you stop moving, your body continues working. Your breathing remains elevated while oxygen helps restore energy stores. Your muscles begin repairing damaged fibers. Your glycogen stores slowly refill. Your heart rate gradually returns to normal. Your metabolism stays elevated for a period of time as your body recovers, a phenomenon known as excess post-exercise oxygen consumption, or the afterburn effect. Hours later, the adaptations continue. Your body is literally rebuilding itself to become stronger, faster, and more efficient the next time you exercise. Every workout sends a message to your body: become stronger, become healthier, be prepared for the next challenge. That is why exercise isn't just about burning calories. It's one of the most powerful ways to improve nearly every system in the human body, from your muscles and heart to your brain, and even your future health. And that's the end of today's video. If you enjoyed it and learned something new, don't forget to